What grade are you in?
Second.
You're in second grade. And Emily, what grade are you in? Third. Perfect.
Okay, let's go ahead. So, Greg and Alan, was it? Emily, I'm sorry. Okay, so what are we doing here? On some of the sites it says something about dance, it says something about art, it says something about group, but it should have an S on it, it should be about groups. What does all that have to do with each other? We're not talking about all dance, we're definitely not talking about all art. We're talking about a little corner where dance and art maybe intersect, and in that intersection there's some mathematics that we can learn. We're going to be talking about patterns that are occurring in borders, and bands, and things like that, and dance moves that may occur on a line, like simply walking or twisting, things like that. It turns out that there's a little bit of math that collects those things and can help you understand what possibilities there are and help you recognize little math when you see it. So the idea of a group is a bigger idea that we can talk about a lot today, but let me see you put your hands up. Actually, do you all have hands? Ah, there they go, 2 hands, okay. Okay, now put them down, but don't lose them. Okay. You know what operations are? When you talk about mathematics in school, what is an operation? A math operation. Okay, have you learned to do things like adding? Okay, what do you do when you add 1 plus 1, right? So plus is an operation you can do with numbers, right? How about another math operation? You know what? Multiplying, right. 2 times 3 is an operation. Division is another operation. Okay. So you know about things that, one more? Subtraction, good. We're actually going to use the idea of multiplying here a little bit. You know when you take 2 numbers and you put them together by multiplying, you do something to the numbers, right? Well, now we're going to go back to your hands. Let's see those hands again. So we can also do things to your hands that have some math in them. So let's take your right hand and just turn it over. Okay, you did something with your right hand, right? Now, you started with your hands down. Now you do an operation and your hands are now in a new position, right? So let's go back. Let's try the left hand. Do an operation over here. And then turn that over. Now you have something new. In fact, that new thing is different than the old thing you've got, right? So is that all we can do with your hands? So you have both hands down, you have one hand up, you have the other hand up. Is there anything else we can do with your hands? That'd be an operation. What's that? We'll turn it over to get your hands up, right? So we actually have 4 positions you can put our hands in like this. You can have them both down, you can have right up only, you can have left up only, or you can have them both up. And how do you get between those operations? You do right hand flip, left hand flip, 2 hands. And that's about all that you can do. So that's a very small mathematical world in which there are some operations that work together to do things. Right? So just to put a point on that, we could represent a right hand flip with R for the right hand. You could have a left hand flip with L for the left hand. And if we flip both of them, let's call that B. Okay? So now this is a little bit different than what you're learning in school where you have numbers. You may have seen letters used in math, but here, these letters are telling us actually operations we can do. So what if we put the 2 of them together? Can we multiply operations? Well, we can think of, sorry? I think we can multiply operations? Well, think of it this way. If I turn this hand over, and then I turn this hand over, but let's say I do right, and then left, what do I have? I have both. So we can have right times left equals both. Okay, we're not going to go too far into this because that's not quite our work. We're doing so much today. But this is the idea where there are mathematical things you can do besides working on numbers. You can use math to work on things. Okay, we actually worked on your hands to do things to your hands, right? That's a lot of what we're going to do today. Where this connects with art is that the idea of symmetry, which is how some people think symmetry is related to beauty, but something is very symmetric, sometimes it's not symmetry has to do with whether you can do something that leaves it unchanged. Like if you have a triangle, you can rotate that triangle, right? And if I draw a very bad triangle and I rotate it, it doesn't look anything special. But if I draw a very perfect equilateral triangle and I turn it the right way, it's the same as it was before. That's a symmetry. So, when we look at patterns, we're going to be looking for symmetries, which are operations you can do that leave the pattern unchanged, leave it the same. It makes it somewhat special. Okay. So, let's look at frieze patterns. Frieze patterns involve the ideas of isometries, which is a big word that says you do something and you leave the pattern unchanged. Well, if we have a blank piece of paper, when you start turning it around, there are a few things you can do that leave that unchanged. You can slide it, which is translation. You can rotate it and it still looks the same. You can reflect it, that is, if you imagine it being a mirror and reflect the top into the bottom into the top, it will look the same. Or you can slide it and reflect it together and it will still look the same.
So we can go from up here, translation, just slide things, reflect up and down, we can slide back and forth, rotate things. Just keep going around. Reflection, sort of like a mirror, just think of it. And then what are we going to do with this? We're going to
slide it and
move
reflect it together.
two together.
So those are operations we can do just on a blank slate of paper that leave the blank slate of paper the same. Okay. But we're going to specialize this now to a little, just like we've made a small mathematical world with our two hands, we're going to specialize from this huge Euclidean plane to a more simple world that is a little more controlled. Okay. And that's the hope. So if you look at patterns and you want to know, well, does this exhibit reflection symmetry? Does it show me rotation symmetry? Does it have this glide flipping thing going on? How can you tell? This is a simple little chart that tells you how you can tell. If you start at the top, you can ask the question, when I do this symmetry operation, when I have a hand pattern like this, does my hand stay a right hand, or does my hand turn into a left hand? Okay, hands are very important in figuring symmetry. So if your hand stays a hand, you might have done a translation like that, or you might have done a rotation like that, which is why this first comment says yes. If your hand is preserved, then you may have done a rotation or a translation.
When we say preserved, it's not like your hand becomes a foot. It's that your hand becomes shaped differently. It goes from right to right. It becomes looking one way to looking the other.
Yeah, it stays like the right hand, it doesn't become the left hand. Now, if there is one fixed point, let's say that, where my hand lines intersect here, right there, if that point stays fixed while I do that change, then I've done a rotation. But if all points change, so there's no fixed point, then I've done a translation. So this chart helps you sort of be a doctor and make a diagnosis. What kind of symmetry is that? So what makes a frieze pattern? A frieze pattern is just a special name for a special kind of pattern, which is any two-dimensional pattern you might draw that is replicated one after another after another. Okay? I like to think of a roll of stamps, because all the stamps are the same, but they come one after another after another. Okay? That would be one example of a frieze pattern. Can you right now look around the room and see if you can find frieze patterns in this room? All the requirement is that it's some pattern that is repeated one after another in a line. This is a very simple room, but there are a couple of them. Yeah, this is very good. This is in fact a very interesting pattern we're going to come back to later in our experience here. So they go back and forth and back and forth, and we'll pretend this is, that's a little glitch in the pattern. But it goes back and forth all the way across the room. It's a very good example. Yeah.
The door.
Okay, here we have, let me use my little pointer so everyone can see what we're talking about. This one's not very good. Oh, oops, that wasn't good. There's a vertical line of symmetry she's seeing here. There's a reflection where this side reflects over to the other side. So it's definitely a reflection symmetry. Is it a frieze pattern?
No.
Why is it not a frieze pattern?
These patterns, they repeat each other, just like those when they're sticking up. They could connect near them, but if it becomes a triangle, there will be a triangle. If you connect all those together, and it will be a triangle kind of.
Right, so here we have a good example of a line, a mirror line and a line of symmetry, but is not repeated, so that was not, then we could make a frieze out of that, but that is not yet a frieze pattern. Anybody see another frieze pattern in the room? Huh. You're a very sharp eye. Okay, she's looking at the end of these mats and seeing that there's these little indentations. There's one little defect here we don't worry about. But yes, it's an alternating pattern that continues in a line. Any others? I'm looking for one person to recognize one more. Yeah? Very good. Very good. So if you look vertically here along this line, these louver patterns are repeated one after another after another. That's a good example of these patterns. So you already see it. You can see these things very, very many places, and it becomes interesting to do a certain kind of hunt to see how many of these patterns you can actually find. So the basic process is we have two things combined in a frieze pattern. We have the picture, or we're going to call the motif of the pattern, and then a rectangle that contains that motif. Okay? So if we erase the pattern and we just think about the rectangles for a while, a frieze pattern is basically a sequence of rectangles all connected. So very significant are the symmetries of this rectangle. How many symmetries are there? Can you tell me? Describe for me what are the symmetry properties of a rectangle in terms of operations like we were talking before? What can you do to this rectangle? Yeah. Okay, let's hold off on the translate and go out because we're thinking about one rectangle right now and then. Well, the slide is moving. Let's just keep it still for now. So reflecting it, we can certainly do that. We can draw a line down here and reflect like this. So we can flip around on the line like that. We have a mirror line here. Yes?
It's not exactly a reflection because one side is
Ignore all the yeah, so we have two mirror lines on a real rectangle. And what else do we have? For just one rectangle? But that no longer has mirror lines.
Yeah, but,
Oh, well.
right.
Okay, the one further symmetry you have is rotation. So why is that like these operations? Because we're actually talking about taking the rectangle, mirroring it, and putting it back down and seeing that it's the same. Okay. So those three symmetries we're going to be wanting to see about. Okay, so here they are, spelled out without the tile. So we've already seen them now. We're going to look for those everywhere we can. So how do you build a pattern? We make a sequence of motifs. You already said that. Now, this is a way of seeing how many possible symmetries there are in the frieze motif pattern. We start first with the case which has no symmetry at all. That's why we have these feet here. Because a foot doesn't have any symmetry, okay? You can't find any line where a big toe reflects to be another big toe, or a heel reflects to be another heel. Okay? So let's just pretend that this little D up here is like the foot. Okay? One of the things we can do to generate little patterns that have symmetry. This has no symmetry, but if we reflect it around a center line and copy it down again, then we get something that has a vertical mirror line. Okay? Yes, exactly. Likewise, we can start with no symmetry again and reflect it in the horizontal and come up with a new pattern that has a horizontal mirror.
Is that right?
Yeah, that would work, or this would work. We don't really care how the foot's oriented, we care about the foot.
Can you hold these for a second? So let's make it clear though. So, let's see if I got the right one. All right.
Those are two. I'm not sure.
Okay, let's try this one. Is this? Never mind. I'll just leave this in. Can't break it. So, there we go. Is that one correct?
Is the bottom a reflection of the top?
So look at it really carefully. Right,
Yeah.
pull it closer. We're getting.
The other one is, no,
Yeah, we don't care about that, no, just that it's a foot.
Why are you shaking your head now?
because if it's
Well,
reflecting,
no, we asked. We're
when
gonna
it's a
go.
right foot, and then
Okay, so how can you tell though from just this picture?
because the toes are opposite.
So if we fold them together, the toes aren't going to line up the same way. Is this actually visible?
Don't do that with my feet.
Yeah, that's
Yeah.
so that's why they're not. Do you agree, Aya?
So we start with something that is like a foot, and we can create two patterns that have symmetry lines in them. The third thing we can do is to take that and rotate it and copy it down. So we take that pattern and rotate it and copy it down. Now we have something that is symmetric under rotation. If you take that thing, and here we have an example, and we rotate that by 180 degrees, and then it's exactly the same. So that's what we're seeing in all these little tiles here. We've made tiles where we have some that have the rotation center in them, some of them that have a mirror line in them. So we have examples of simple feet. We have examples like this that have 2 feet side by side. We have an example of them rotated. But now, if we take any two of these and do it again, so let's take this thing and flip it around the vertical line, we get to here. If we take this and flip it around the horizontal line, we get to here. If we take this and rotate it once and copy it down again, we get to here. So it's sort of like with our hands, where we had right hand flip and left hand flip, and then finally put them both together, we get a new pattern out of the 3 by combining. So now, question for you to scratch your head for a moment. Is this it? You might think no, because I'm asking that kind of question, but we've made 5 patterns, and we can now start replicating and put them on stamps, and stamp out patterns. Is there anything more we can do with these? Any more patterns we can find?
Is this everything you can do with your feet?
We can really do a lot of things that are not patterns, so we're not worried about that. Yeah, everybody thought? Well, it's a leading question because, I'm going to skip over this. So this is the part where now we take the pattern and we do that stamping thing, just to quickly see with your eye what those various symmetries look like when we string them together. So if you take the basic foot, which say over here beside her, and start replicating that down the line, this is the kind of thing you would see.
So what would this look like? So we want to kind of demonstrate what this would look like?
You can actually do this. You want to do this?
Okay, show me what this looks like.
Is there any other way you can do that? Is there another way you can do what you just did? Okay, that's one point. You could hop forward on the right foot, and you could hop forward on the left foot. You could also turn this way and hop sideways, right? So, part of what we want you to realize is it's not about which way your foot is pointing or which way your body is moving. It is the fact that there is a non-symmetric motif that's being copied one after the other. Now, this one has our rotation symmetry replicated down the line. So you can think of this as rotating here, or if you like, you can rotate it and put it down here. You can rotate it and put it down anywhere down the line.
So what do you guys think? Just think to yourselves really quick. You saw what Gregory did before with the hop. That was 1 foot, right? So what's going on here? What do you think? You have to think to yourself. Just think to yourself really quick. Imagine what's in your head. And like you can even stand up and start imagining what it's going to look like.
Does anybody besides Gregory want to do this? Want to try? Okay, just take the space up here and try. Okay, we got you a little bit. Stay up here because we're going to try to fix that. You have a good idea. It's not quite there. Why? Because this right foot gets rotated around, and it's still the right foot. Okay. Can you hold it?
No, you got it. It is okay.
So, this, I'm sorry, it's printed as a left foot. So this left foot, when it's rotated around, is still a left foot. So you kind of have to do this on 1 foot, but still do all that twisting. It's kind of hard to do. Can you get it? There you go.
Oh, you've
Perfect.
been trying all day and you haven't been able to do that.
That's right. I didn't have to do that.
It's true.
It's not easy to do. It's very agile.
You can practice it later on. It'll be great.
And that's why it's called dizzy hop, because it's hopping, but it makes you dizzy. If you keep going the same direction, some people do it and then twist back the other way to get their ear reset. But some people, if you just go one after another, no, you get dizzy pretty fast. Okay, next one. Remember, these are feet. So what kind of feet do we have? Let's call this a left foot. What is this? Well, let's see. Can we rotate into it? Can we rotate the top one into the bottom, or do we have to?
It's still left
Is it left or right? So, I'm going to make this my thumb, okay? So if I rotate that, my thumb's on the wrong side, right? And that's a property of reflection. The reflection changes a left foot into a right foot, a left hand into a right hand. So this pattern has 1 left foot and 1 right foot. That would be like that one, okay? So we can, now which way is it pointing? Does it matter? Is it pointing feet up like this or feet sideways like that? Why is it sideways? I'm not saying you're wrong, I'm just asking. But we're not quite there. We're going to hold off on that just a few seconds because I'm just thinking about this by itself. Okay, we're moving ahead. This is like the left foot, and this is like the right foot because of the reflection. And this is reflected, which means my left hand up here, my right hand down here, my left foot up here, my right foot down here. So a pattern that looks like this would be, in fact, my 2 feet like this. Left up and right down with a line of symmetry in between. So this is like the line of symmetry of your body here. Your left foot and your right foot. Can you see that? Okay, so. Right. Now can you see it better? Yeah. So now, if somebody want to do this, I'm sorry I forgot your name. You want to try? You want to come out and do it? So this is a straight line of patterns like this. How was it?
Like it.
Very good. Good length. Good length on this thing. Okay. So that is simply called jump for obvious reasons. Now this one, what about that? Now that you understand, this is a left foot, what is this? It's a right foot. Right? Remember the left and right. And the line of symmetry in between. So it is like standing there with my toes pointing at you, right, with the vertical line of symmetry this way. You understand that? Who wants to do that? You want to try that? Very good. Exactly. Now, I'll show you another way, which is for us older people who are not so energetic. Okay, you can stand in foot like this, take one big step sideways. Right? In fact, that's why it's called sidle, because this is kind of a sidle step. So that's not so hard. And finally, this one. Somebody's got to try this one. How does this one?
Oh.
Maybe you know, it's good because it's a good partner thing. We'll have two of you come out here.
Oh, I know.
Because this thing takes a left foot and a right foot, and a left foot and a right foot, right? Yes. How do you count together? There you go. Very good. Wish I had you here this morning. That would have been a lot better.
Yeah, we tried the two of us to do it this morning. Adults can't do this.
Yeah, it's a kid's thing. All right, so what we've done is we've gone through those 5 basic patterns. Now I need to ask my question again, is there more? Okay. And there is a little bit more. In the interest of time, because this takes a little time to explain, let's go ahead and do it with the tiles. Can I get upwards up here in the front? Yeah. Just horizontally.
Definitely got to write on the back.
Okay, so what does that look like? Just describe it. Let's not worry about math. What does that look like? It looks like walking. In fact, it looks, well, we don't have one up for that. Yeah, it just looks like walking, right? I can't even walk. But can I have you still up here? Because these are a little hard to hold. Okay, good. So, but it turns out that to me, this is actually one of the more mathematically interesting patterns for a reason that is not immediately obvious. So if I take this is just like one of those patterns, right? And I set it down on top. Pretty obviously this is a freeze pattern because I can go down the line and replicate it and replicate it, right? But I can do something else. There's something about the left and right feet that are related here. In fact, if I take this up and don't just shift it, but I shift it and flip, look where I end up. Oops. Where do I end up? The word is there. It's in between, right? Now if I go another time, I end up back in the place where the freeze pattern might expect it to be. But if I flip and rotate, again, I end up halfway in. Now, that is something that arises because we have both the symmetries of the tile by itself and the translation working together. Remember with our hands, back to this, we had left hand and right hand, and then we ended up with both. We had to do 2 things at once, and we got something to do. So here what we're doing is we're taking the local, what's called the point symmetry of the motif, combining it with the translation symmetry of the frieze, and we get that there's a new symmetry that shows up. That's called the glide. And it's not that hard to do because you can just do it walking. Okay, so that would be important. So that's a new pattern that emerges because we're doing the freeze. So here's what we just did. Left foot, right foot, left foot, right foot, left foot, right foot. But because this is halfway in between, we can do that flipping. There's one more like that, and that's another 2-person. this way, 2 feet pointed back this way, 2 feet pointed up this way, 2 feet pointed back this way. Okay, whatever it is. But now what's the unit? The unit is actually this, 2 things together. And 2 things together. I can't do this with the tiles, but you can imagine that if you pick this up, these 2 things together, pick them up, flip them over, and set them down halfway, you can see that this one right here, and this one right here. So this has that same symmetry on line, but it also has a nice vertical symmetry. So you want to try this now? See if you can put this together? So you're trying to skip? Yeah, you're trying to skip places? Okay, I'm going to do it. How about this? Let's have you face me and you decide and face out. Now look at your feet. You've got them, but they're not oriented right yet because you're oriented that way and this is oriented this way. So now let's rotate. You face the wall. You face the others. And then you do a little bit this right this side. Go back and go. Now, if you have really, really big jumping muscles, you can both jump up and twist around and then go to here. Right, but you'll be doing it. So that's kind of hard to do. You want to try it? Oops, almost. Almost. But that's the idea. That's what we're doing. So, we've already done a lot of this exercise, but now what we'd like to do is to have you play with these tiles here and put together patterns that you can actually bounce through and try. Okay? You're going to set them down in several places because they have different patterns on them. So let's take a look at what they are. This one has the 2 feet together. Those work together to make a nice set of patterns. So we'll just put those out here in the middle. Okay? We have our walking tiles up here. We have our spinning tiles here. And then a bunch of 1-foots, which we can put in the middle. So pay attention to the fact that each one of these really works by itself, that we can't always shuffle them together, they don't have symmetries in them. So you can feel free now to go to whichever one you like and put together something and see if you can actually bounce through. Okay, go ahead. You too. You can make a lot of things.
I think one of those is the right one.
There are 2 right, 4 left. That's interesting. So what do you think?
That's crazy. Not really.
So these are good.
I went on this.
Is this all the same direction? Oh yeah, so this is all clockwise, right? Okay. Does that make a crease?
Oh wait,
It does, it's in the corner.
that's just so easy.
That's one way to do it, right?
Do you have the ballerina?
Yes. In fact, let's put that up. That might be easier here.
Oh, you did it, oh, perfect.
We're calling it. Yes. Oh, look, danger.
Oh, look at the video.
This is not very exciting, but it shows you what you can do.
Oh, look.
Wait, look, it has some.
I looked at Crystal, she wasn't anything else.
Oh, these. I'll put them in the pocket. That's good.
Fortunately, we don't have all 7 patterns. The video didn't work for some of them.
Oh, yeah.
That's what you guys. It doesn't feel bad. No, we were doing something.
You can make that with your zone. You can make
Let's
that.
check. Oh,
You're going to have your toes.
what?
If you connect the toes to toes, toes to toes and heels to heels.
No, we can't. No, because these feet are facing differently. She was just going like this.
No,
Yeah, ours, they have to be going like this. But now I twisted these. We have to go like this. You're making it too hard. Something like that. You're making it too hard for yourselves, you know?
well, can I try yours?
No,
Give him a chance to try that first.
let's check this one.
So that's a face mask. So see if you can do that one out.
Wait, no, that's not.
Good. There you go. Very good. That's just the step
We're
pattern.
mixing it up. But one, two, this one, two.
About trying one with the heels or toes pointing outward.
Outward?
Into the getting your toes down. Being like this, or like that. And you make one with the toes on the top.
Oh wait, you just gave me my feet.
Okay.
Oh, that's not that.
You got it. When we made it, scoot it down like a foot so you don't hit the ground. Awesome. Or you can go with it.
Oh, we can.
You mean all of them like this? All of them.
And then starting
You can jump any way you like. So is this the idea? All in the same direction? Okay. Remember what this one's called? Do you remember what this pattern is? Try to see
going for something else. I'm actually going backwards. Jump.
Okay.
I want to see it bigger.
That's what I'm trying to do. Yeah.
Emily, just with your left foot.
What?
Stand on one leg and practice with one leg.
Yeah, look at where the toes are again, the big toe.
Have you done it as a competition? Where students like.
Is that your daughter, Emily?
You can't really do that otherwise.
Have you tried that?
Oh, you can.
You guys can hit it right halfway through this.
Something a little crazy.
So when you hit
I'd like to,
Maya, feel this. You just got to ask Okay.
so keep those right. Second one.
If you mess up your hands, I just messed up. Oh wait, no, I messed up.
That's it.
So what is? No, I know that one. Go to that one. I'll go this one. And then you messed up. No.
Hands the same.
And then that one cleaned up. Yeah.
Don't worry. Let's try a different pattern. Hold on. I'm still on here.
Okay, that's a separate group. It doesn't go with this one. Because that has rotation.
This one.
Okay, so let's see what you can do with this.
It does, because someone's supposed to do it, see? So,
Probably pretty easy for you. Yep.
Is there a different way to do
do
that?
something more difficult. Ours is difficult. I think these buttons
So we want to full turn?
are harder.
Okay, well,
Pattern, just to let you know that's not a pattern.
so if we could get you back to your seats for a while, we can come back to this at the end. We'll just leave the tiles here for you to, maybe you think that we're crazy patterns to do.
Wait up. Hey, don't do that.
We're gonna do something a little quieter, a little more still for a few minutes. So this is, well, part of the reason to do this is as you leave here, you're gonna start looking at your feet and you're gonna start realizing which pattern this is. And you're gonna start jumping around. People say, well, why are you jumping around so crazily? And you're gonna say, well, I'm doing this pattern and that pattern. But to help you sharpen your eye to be able to see these things, we have a little bit of an exercise here for you. And to, actually to build this exercise, you need to spend a little time at the board. Can you flip that metal switch right there that's going to take the, yeah. Oh, I'm sorry, all the way up, yeah. Just put this on this.
And then how does he pull it back? He flips the switch down.
Again, let's spend just a few minutes here on names because we want to talk about the patterns, individual patterns. We talked about jump and so forth. There's another system of naming which is a little more mathematical. It is the system that comes from crystallography. It focuses on the ideas of vertical mirrors or horizontal mirror or rotations, which are all twofold rotations. And of course, the black. Okay? And the system uses two symbols, either letters or numbers, in side by side like this. Okay? So the first question you want to ask is, does my pattern have a vertical, this is the vertical box and this is the horizontal box, does it have a vertical mirror or not? If it has a vertical line of symmetry, we're going to use M, which means mirror. And if there is no such line, we're going to just use a 1 as a spaceholder. Okay? So this will be either 1 or M in the first box. In the second box, we're also going to have a system of symbols. We use N again if there's a horizontal mirror. We use G if there is a glide. Remember we talked about what those glides are. A 2 if there is a two-fold rotation. Or if there's none of those, just a 1. Okay? So the second box does twice the work of the first box. And that has to do with the fact that it freezes a horizontal thing and not a vertical thing. The vertical doesn't have much to do. So what we're going to do is pass out to you some strips of ribbon, which you just reach in the bag and pull out a few pieces of ribbon. Not too many, the room will get messy. And we'll just see what we get. And see if you can figure out by this system, does it have a vertical mirror or not? In the horizontal, does it have a mirror or does it have a glide? Does it have a rotation or nothing? And we'll try to figure out what all these patterns are, okay?
Do you guys know what horizontal is
Yes.
and vertical?
Yes.
Just a few.
Alright.
Yes.
Yeah, I get confused sometimes.
Yeah. Take some out. And you all can do this too. You want to try this?
Oh, yes.
Okay, so this is a chatty thing, okay? You can talk to each other about it, you can ask questions, and when you think you have an idea what one is, you can ask me, and we can get it together.
Awesome. So what happens?
Yeah. Oh, I thought you were all sharing this. Yeah.
Yeah, so that was, so we aren't looking at like all of the ribbons together, we're looking at a given ribbon. Is there a pattern on a given ribbon?
Yeah, pick one and see if you can figure out what the pattern is on that one. And when you think you have an idea, just talk to them about it.
What kind of pattern is this? It's a 9.
We just finished with it now, yeah. Yeah, that's fine.
Really finished with it?
Yeah. Yeah, but
Chop it into one piece.
Okay, and that purple, green, orange just keeps on replacing it. Like it starts at one purple and then you sort of pick it up and go to the next purple. So what happens when you're picking it up? Is it doing funky turns? Is it doing?
No, it's just like, it's doing,
It's doing. Okay. So it's rotating. So if we take this one and it had this pattern, how would I like line it up? Would I line it up by moving it this way? By turning it around this way? How do I make this one line up with that one? Oh, okay.
So we're looking at it this way, right? So let's ask the question. When we think about the symmetries, we think of it this way, okay? Is there a vertical mirror?
Okay, so the squares are actually like sort of moving down on a vertical.
So
Okay.
let's ask the
So if
question,
we
does
look
it
at
have a
the
vertical line of
colors,
symmetry?
they just
No, it
shift
doesn't.
over.
Does it have a
But you're saying
horizontal
that if the
symmetry?
squares,
Okay,
these
is it the same
rotate
if
around
we flip
instead
it
of
over?
I don't like it. What about this
Okay, so
one?
fine. Look at
Or
one
that
foot.
one.
Let's just look at
Did you
that.
get this one? Did you talk about this one?
Yeah, so if you focus in on just one pattern there and flip it upside down, it turns over.
Same shape.
Same shape.
Okay.
But it's not a mirror because it doesn't reflect. Okay? But if we shift it and reflect, remember that one? If we shift and reflect, this will go onto that. Remember what that was called?
So if this was your big toe
That
and
was
that
the
was your
blind.
heel, what would it look like?
Combine the translation and this. So the pattern here is 2 feet together, right? So if we translate by half and rotate, then, yeah, so this is the goal. If we take that and translate and rotate that. Maybe, that helps you. So, is there another interesting one?
Yeah, it's like the shape
Do you want me
of
to
size.
take
And the energy pattern.
Oh, so bad.
So
Very bad.
is this, it's a freeze pattern. Okay, let's look at it this way. I'm going to take it horizontal. And does the pattern repeat? Does it?
Two patterns.
Right. So the one job is always to find out what is the pattern, what is the motif. And so here, the motif has 2 things in it, right? But it does repeat. So it is a freeze pattern. And now we need to ask the symmetry kind of questions, right?
Oh, okay.
I think it's horizontal.
Okay, now you can sort of see through it. So if we flip it over, is that the same thing?
In other words, we can look at the middle of all of them.
Okay, so there's no vertical
I think I understand.
and there's no horizontal. Now let's ask about the glide. What has to be true for the glide?
Other one, just going down from this and that.
The same.
So if I reflect it on the
Right, right.
same one,
So the key
True.
to
So if
remember
we
when
would
you're
translate
trying
by
to say
half
this
and
is
flip, we would add orange on top
What's
of
different
brown.
between
And is that a repeat pattern? Is that the same thing? Yeah, so it doesn't have a glide. Because that would be the glide. You can slide by half and flip and we have the same thing. Here we can slide by half and flip, but then we would have orange on top of it. So this one actually doesn't have any symmetry. This is our most basic. This is like a 1 foot.
There's like a one.
Yeah, 1 foot. Right. So you have 2 different ones there. You have a glide and
Okay,
you
so let's
have
see.
a 1
So
foot.
the stomach's going this way, and if we rotate it 180
Okay,
degrees.
well, put it horizontal like this, and then ask the question. Yeah, yeah, so there's no vertical, right? But there is a horizontal. Is there anything else we could say? Is that
So what's
implied?
the difference? What sort of like this one versus
It's
this one?
reflective.
The longer
So this, because there's no vertical line, we have a 1 in that first position. But because it does have a horizontal mirror, we have an N in the second one, so this would be 1 N. So that's a new one for you. 3 different ones.
So it's kind of talk them between the glide and the freeze pattern. So then let's take a look at the one that's kind of one of them.
So what if I
And we want
asked
to do
you
the
this
systematic
one
questions. So
instead of just
hold the
looking at the
horizontal
individual
position
parts? So I
and
use
ask the
rotate
questions. Is there any vertical
this
line of
curve right
symmetry?
here. Just this section right here. How do we take and change this one to get to the next one?
Yeah, so if I put down lines like this, is there any line there that would be in the line of symmetry?
I
What
just made the whole
about
entire,
the
this whole
middle?
rectangle.
It reflects this one and that one, but that's fine.
But it would be the same.
That's right. So this has vertical symmetry and horizontal symmetry. So in terms of our naming system, that would be mirror. So you have 4 different ones.
Do they line up exactly? And we can't really do that with this one.
2, 1, 2, 1.
Does it have a vertical line of symmetry?
Okay. Oh, okay. But that's not.
In there somewhere, and you want to email me those pictures, I will post them on our website, and in the gallery we're going to build a freeze patterns. But it'd be best if you can actually figure out what it is and tell me what you found. Then I will. And then Brandy is behind me, Brandy Wiggers. This is Sage and Simone, and here's Simone. So those are all of our presenters.
So did you guys have fun today?
Yeah.
If you want to take these ribbons, go ahead.
Special one. This one he wants.
This one? Right, so the way I like to think
Nice
of it
imagery
is
to
starting
define.
like this. You can ask the questions. Is there root one? Is this one